Dear students, in this lecture we will discuss the extent of reaction and effect of the equilibrium constant. Okay, we will predict whether the product is obtained in higher quantity or whether product is obtained is lower quantity and reactant is obtained in higher quantity than the product, or whether product and reactant is present in both is same quantity. We can predict by using the equilibrium constant. Okay, this prediction we can do by using delta G equation. We know that the delta G equation is equal to delta G naught plus RT ln PB upon PA. Okay, then equilibrium constant in terms of concentration, we know that in this case this can be replaced. Okay, Q, okay, this PA and PB. Okay, other equation we have delta G is equal to delta G naught and plus RT L and Q. And Q we can given as the concentration of reactant upon concentration of product upon concentration of reactant. Okay, therefore your delta G is depends upon gives free energy is depends upon the partial pressure of the product and the reactant, or the concentration of product and the reactant is required. Okay, therefore by using these values, by using the G values, we can predict the extent of the reaction. Okay, first things you have clear that your delta G, the change in free energy depends upon the partial pressure. Okay, this quantity is the constant quantity. This quantity is the standard change in Gibbs free energy. From the standard state of the reactant, you will obtain the standard state product. It is difference between the Gibbs free energy when standard product obtained from the standard state of reaction. This value is a constant throughout the your reaction, but this value is changed. You can measure this value throughout the reaction at any stage. Okay, when delta G will be 0, it means the equilibrium is obtained. Therefore, change in free energy depends upon the partial pressure and the concentration, because Q is included in this equation. Therefore, this delta G value is depends upon the concentration and the pressure. Okay, so for this we have the first graph is there where your reactant is reacted and like that way it reacted. Okay, it is the pure reactant and the product. Okay, pure product. Okay, and at this side there is a progress of reaction. And the Gibbs free energy, this side is the Gibbs free energy increases like that. Okay, therefore at this point your reactant is more, and at this point is your product is more. We have already discussed that as your Gibbs free energy is higher, the system is try to obtain the particular by losing energy is try to obtain the stable situation. Okay, therefore for the reactant the Gibbs free energy less than the product, and this is G1 is there and G2 is there. Therefore this is having the higher Gibbs free energy. Therefore reaction will be higher in quantity to that side. Okay, at that point, okay, this point and this point, okay, there is this and this is the delta G naught. Okay, this value is the delta G naught, and when you remove the G2 minus G1, that is the G2 minus G1, when you consider, therefore G2 is the higher value and G1 is, therefore delta G0 is the more than 1. Okay, remember in this case delta G0, sorry, not 1, delta G0 is more than 0, because G2 value, when you remove G2 from G1, its value is the more than 0, because this value is the higher in quantity. Okay, therefore at this point there is a equilibrium. Okay, at this equilibrium we know that delta G is equal to 0. Okay, therefore in this case you found that more and more reactant is there because it is having the less G value. We have already said that the system or the your reaction tries to obtain the less G value. For less G value, for this is the reactant has the less G value. Therefore product try to move to the at the reactant side. Therefore we know that Q or K, okay, at the equilibrium your product concentration upon the concentration of the reactant. Okay, in this case you found that reactant is more in case. Okay, in this case reactant is more, because your reaction is obtaining the product rather than it obtain the reactant, because the G is the less. Okay, therefore for this K is this product value is less. Okay, and reactant is increases, therefore K value it is less and it is increases, therefore that value is more than is less than, okay, sorry, this value is less than 1, but by considering reactant is the more, and therefore K value is more than 1. Therefore at this case more and more reactant is obtained. Okay, if K is the more than 1, more and more product or sorry reactant is obtained, like this situation. Second situation is like that. Okay, second diagram is we have draw in this case. Okay, from product to you obtain the reactant. Okay, therefore this is like that, you draw like that, and this value is delta G not. Okay, therefore the product, okay, this is reactant side, pure reactant, and from the you obtain the pure product. Okay, reaction in this side, reaction progress, and in this side Gibbs free energy. Okay, G is the Gibbs free energy. Okay, in this case G1 and G2. Okay, therefore G2 minus G1, G2 is the less G value, that is product, and G1 therefore it is negative value, therefore that is the this value is less than the 0. Okay, this value is 0, more than 0, and this value is less than 0. We decided G2 minus G1. Okay, at that point your equilibrium is there. At the equilibrium delta G is equal to 0, and from higher energy reaction will be moved to the lower end delta G. Therefore reaction in this case more and more product is obtained, and K for this reaction in this case more than 1. In this reaction by using this, in this case product is more, therefore this value is more, and your K value is more than 1. As such situation your product and obtain more and more when K is equal to 1. Okay, then third situation is like that. Okay, pure reactant and pure product. Okay, at that point your equilibrium delta G is equal to 0 and K is equal to 1. In such reaction the maximum product and reactant is maximum in number. Okay, in this side product is also more and the reactant is also more at the this equation. Okay, I hope you learn this, the how much extent your reaction is the proceeds when by using the delta G value, that is change in Gibbs free energy. Thank you very much.